everyone. I'm Rose Wang, Manager of Data Analytics at RMI. I'm glad to walk you through WasteMAP, our digital platform for mapping and mitigating waste sector methane emissions. I'm going to share my screen now. This is a homepage of WasteMAP. I'm going to highlight two main features on WasteMAP: an interactive map on the left-hand side and a suite of decision support tools on the right-hand side. Let's start with the map. This global view shows country emissions. Each country is color-coded with the per capita methane emission from the waste sector. Let's click Mexico as an example. This chart shows the time series methane emissions for Mexico. If we click on this panel, we can see a list of waste disposal sites, a comprehensive country report, and the emission ranking of Mexico. Zooming in a bit, each navy dot represents emissions modeled for a specific city. Click Monterey as an example. We can see the methane emission rate for Monterey and methane and waste generation rate. We can also see the current waste characterization and the current waste management practice in the city. Users can enter the City Decision Support Tool or City DST by clicking this button. Zooming out a bit, all these orange dots represent disposal sites, including landfills, dump site, or controlled dump sites. The darker orange dot represents sites with satellite observations. Let's click one. We can find modeled emission for this site in this site info card. We can also click Plume View to see the latest plume image we have for this site and plume emission time series. Users can click this Decision Support Tool button to enter the site DST. Now let's go back to the home page. The major upgrades we made to this year's DST is an expanded city DST and a brand new site DST. We will start from the city DST. The city DST is designed to simulate policy scenarios across the waste value chain of a city, including upstream waste generation, midstream diversion, and downstream disposal. Let's take an example. Let's take Rio as an example. As you can see, after Rio is selected, we can see its baseline emission in this chart. Rio has set an ambitious goal to reduce food waste by 50% by 2030. To model that scenario, we can set the scenario starting year as 2030. As we move this slider, we can see how the food waste prevention policy affects the methane emission. This is designed for policymakers to evaluate impacts of interventions such as expanded composting program, increasing recycling capacity, investing in new anaerobic digestion capability, or create a new landfill with efficient gas capturing system. Now let's explore the site decision support tool. We can enter it from the navigation pane here. This year, we also introduced a user account system in WasteMAP that allows users to save individual scenarios in their personal dashboard. To save some time for data entry, I'm going to load a scenario I have already modeled for Navotas sanitary landfill in the Philippines. The Navotas scenario is now populated. As you can see, there are two columns of data. The left column contains inputs for baseline emissions modeling, while the right column is used for scenario modeling. When modeling a specific site, users first enter site-level data such as waste amount, waste composition, the site type, and other operational details such as biocover or gas capturing system. For Nevatus, we have 2 satellite observations. These observations suggest an average annualized emission of about 27,000 tons. As you can see, our baseline emission for this period is aligned with the satellite observations. Now let's simulate a decommissioning scenario. The Nevatus site was closed earlier this year, so I'll enter 2025 as a site closure year. You'll notice emissions drop significantly. This blue curve represents the scenario modeled. For illustrative purpose, I'm going to simulate an alternative scenario, which is to add a gas capturing system with a relatively high capturing efficiency, and the implementation year is 2026. Let's see the impact of that scenario. As you can see, when we have a gas-to-energy project for Nevatus, and that gas capturing efficiency is very high, we can see a significant drop of emissions starting from 2026 as well. The site EST enables policymakers and operators to model and compare interventions at disposal sites to identify effective mitigation options. Beyond GCCS, the tool supports scenarios such as reducing incoming waste flow, converting an open dump site to a controlled dump site with gas capturing system, adding a biocover to a disposal site. Finally, let's return to the user dashboard. A small but powerful feature I'd like to highlight is the data sharing option. If you select yes to share data, your inputs will be securely shared with the WasteMAP team. This enables us to validate data sources, improve data quality, and continuously enhance the platform's data accuracy. We invite you to join our open data community, working together to deepen our understanding of methane emissions from the waste sector and to design effective mitigation pathways together. That concludes the WasteMAP demo. Thank you for joining me.